So we have a system of equations, two equations with the same variables. We're interested in where these two lines intersect. So since all the variables are on the left-hand side of the equal sign and the constants are on the right-hand side, I'm going to go ahead and choose elimination to solve this system. Now, you may be looking at the system and immediately going, I don't like this one because of the fractions. Remember, you don't have to deal with the fractions. You can, in fact, eliminate the fractions from the very beginning if you wanted to. Look at your denominators, 4 and 3. Common denominator between 4 and 3, or think of it as the least common multiple between 4 and 3 would be 12. So why don't we go ahead and before we even start this problem, let's multiply the left-hand side, and of course what we do to the left we have to do to the right, so we'll multiply the left and the right-hand sides of this equation by 12. So in doing this, we will eliminate our fractions. It's going to look like this. Let me rewrite it so we can be clear. 3/4 x plus 2/3 y is equal to 2. So if I'm multiplying the left-hand side of the equation by 12, as well as the right-hand side of the equation by 12, that's requiring me to take this 12 and distribute it. So I'm going to be multiplying 12 times the first term, 3/4 x, but I'm also multiplying 12 times my second term, 2/3 y. And then the right-hand side of the equation, I'm just taking 2 and multiplying it by 12. So now I know 4 divides into 12 3 times, so 3 times 3 leaves me with 9x. And 3 divides into 12 4 times, 4 times 2 leaves me with 8y. And the right-hand side, 2 times 12 is 24. Now, I know I showed a lot of work to explain that step, and that's wonderful if you would just do all that in your head and come up with the equation 9x plus 8y equals 24. I just wanted to make sure I was explaining it step by step. So now we're going to use this equation, put it back together with the original second equation, and now we have our system of equations, and we don't have any fractions. So let's rewrite that. So now my system looks like this. 9x plus 8y is equal to 24. And 3x plus 2y is equal to 4. Now we're ready to do our elimination, and this problem probably looks a little better to you because we don't have any fractions. So we pick, do you want to eliminate x or y? Let's say we choose x. So the first term is a 9x. I need my bottom term underneath it to be a negative 9x, so that will end up with a 0. I don't have a negative 9x down here, I have a negative 3x. So I'll need to multiply my second equation by a negative 3, and then balance that by multiplying both the left and the right by negative 3. So this gives me negative 9x minus 6y equals negative 12. Let me rewrite my top equation, 9x plus 8y equals 24. So now I can add straight down and do my elimination. Notice that the x terms will subtract out. I'll be left with negative 6y plus 8y is 2y, and negative 12 plus 24 is 12. And that, once I finish solving, will leave me with y is equal to 6. So remember, we're interested in the intersection of the two original lines. So we just found the y value, which is 6. So it appears that would be the y value of my ordered pair. And then I'm going to take this y value and substitute it back into one of my original equations. And it doesn't matter which one. You probably are going to shy away from that top equation because of the fractions, which would be fine. So let's say I substitute it back into my second equation, which was 3x plus 2y is equal to 4. So we just found that y was equal to 6. So I'll substitute 6 into that equation and solve for x. We'll have 3x is equal to negative 8. Looks like x is equal to negative 8 thirds. So that would be the x value for my intersection, and this is the solution to my system of equations, negative 8/3, comma 6. So we have two different ways of classifying this particular system. Because we got a solution, we could call this system consistent. A consistent system of equations is a system of equations that has at least one solution. And then because the two lines are different lines, we could also say this is an independent system. The two lines are independent of one another. So this system is both consistent and independent, and the solution is negative 8/3, comma 6. I encourage you to go ahead and use your graphing calculator to check our solution. Just remember, when you're using your graphing calculator, going all the way back to the original two equations, you're going to have to go ahead and solve both of these top equations for y, so you can put these lines into your graphing calculator in your y equals screen, and then calculate the intersection and check that you get the same one that we have here, negative 8/3, comma 6.